Hi, my name is Kayla Clausen and I completed my placement in the Shanghai International School. So, when undertaking placement in the Shanghai International School, the process of planning and teaching a small scale investigation was not undertaken completely, although multiple lessons were taught with guidance of my mentor teacher solely for this assignment. So, the following evaluation highlights what I taught, what was observed during placement, and what I learnt from my time in Shanghai as a pre service teacher. The investigation was planned prior to starting placement, meaning that all requirements of the assessment haven't been met. So, taking on the role as the teacher, I tried to adapt the mentor's lesson to carry out a mini investigation, which saw students successfully explore their surroundings through scientific analysation and questioning, whilst obeying by the mentor's strict instructions. So, as the Chinese school had their mandated exams coming up in the following week, it meant that many lessons couldn't be changed due to this. So on my third week of placement, I had the opportunity to teach 2 double lessons on the topic of shadows to half the Year 4 cohort. The topic aligns with our Year 5 substrands of physical science, so light from a source forms shadows and can be absorbed, reflected and refracted. So this meant that students were understanding and classifying materials as transparent, opaque or translucent based on whether light passes through them or is absorbed. The topic also allowed students to develop, understand and investigate the concept of light through engaging scientific activities on the basis of their physical world. The initial aim of the double lesson was for students to recognise that shadows are formed when light from a light source is blocked by a solid object, through investigating the best material for their curtains in their bedrooms. So this was explored through using concrete materials within the classroom and general discussion throughout. The science inquiry skills used within the investigation included explaining how light travels, sorting out different materials according to whether they are opaque, transparent or translucent, and using these materials in an investigation to show different shadows. As this was the first and only science lesson taught to both classes, I was unaware of the students' prior knowledge in regard to shadows, although it was evident through discussion with the mentor teacher that students had a developing understanding that mirrors can be used to reflect light onto different objects and why mirrors are good reflectors. According to some course readings, it was mentioned that students' prior knowledge is deemed vital in the teaching and learning process, hence why it was important to implement activities and/or discussion that allowed students to make sense of their world and scientific ideas learnt prior to this investigation. When starting the shadow lesson, I used the students' prior knowledge of reflection to create discussion and gauge where students were at using the understanding of light through a different concept. Through learning drawn from the course experiences completed over the unit and associated readings, I understood that teachers, including myself, had to explicitly discuss and teach students the specific aspects of science within the context before actually completing the science itself. In addition, and according to the textbook, teaching primary science allows teachers to inform students what it is meant by light and take an unproblematic and obvious answer to the next level. So by doing this, I was investigating what students understood, as well as covering a range of interesting conceptions through natural curiosity and critical and creative thinking. Implementing learning experiences that were hands-on encompassed the learning of science within the class, evident throughout the lesson. So using hands-on and creative thinking was something that the Chinese students weren't used to and took some time for them to grasp the idea. The learning sequence consisted of how light travels, addressing the students' misconception that light can only travel in a curvy line. So through explaining this misconception, students were to create a model or experiment that demonstrated that light does travel in a straight line. So whilst completing the experiment, students were asked questions that generated and prompted science inquiry for the investigation. So by creating this science inquiry, the students were becoming active participants within the lesson. The questions that were planned to inquire were modelled by myself at the start to reflect the depth of thinking I expected from the students. So the initial question based around the investigation to be inquired into was, what curtain material could be used to block out light? So using this initial question as a starting point for the students, they were applying their knowledge learned into the different contexts, such as their bedroom, to engage in higher order thinking. Students within the Shanghai International School found it difficult to become effective questioners through inquiry, as it was uncommon to their normal learning practice. This was because their normal science was based around a textbook, where the teacher would demonstrate something and the students would write the answer. So students weren't necessarily used to being active learners and using group work to come up with an initial answer. After investigating that light travels in a straight line through experimenting, we started to heavily focus on opaque, transparent, and translucent objects. So focusing on the fact that opaque objects block light. So by doing this, we used the resources within the classroom to classify which one was which. So through exploration and greater discussion of the three terms, students were given the opportunity to make hand shadows using the projector and smartboard. So this was also demonstrated and talked about that our hand is an opaque object which blocks out light. So by integrating exploration activities, it ensured that students were developing a conceptual understanding of shadows, as well as perseverance and open mind and questioning. So unlike Australian schools, incorporating a constructivist teaching model was harder than what was anticipated. Within the lesson, teaching strategies that aim to orient and engage learners were implemented but not necessarily mastered. So according to the textbook and something I taught from the coursework completed, classroom context, student goals, expectations, and needs, as well as their interests, are attributes that should be considered when incorporating a constructivist approach. Although the lesson was planned by a mentor teacher, it also meant that I was limited to conceptual change. Through the investigation, students were using the knowledge they learnt to write a detailed explanation about the science they have learnt in the investigation. So as the teacher, I was looking for students who could communicate their understanding of how opaque materials block light. So this was through verbal communication, or even getting them to show me their understanding through using concrete materials. The science inquiry skills that were targeted and the concept skills learnt through carrying out the investigation was to effectively recognise that students are formed when the light from a light source is blocked by a solid object. The majority of the students had a clear understanding of opaque, translucent and transparent, although some students were mixed on and had mixed opinions on which one was which. So through the investigation, students were able to identify if different materials could be used as curtains to block out the light and which one would best fit. Exploring students' ideas about light sources and more specifically shadows that can be absorbed, reflected and refracted, it provided students with an elementary scientific basis of the concept energy, as well as providing the opportunity for enriched learning activities. As the pre-service teacher conducting the lesson, I learnt that teaching international schools, or more so, should show emphasis on teaching guided and extended inquiry. So instead of presenting and teaching science through a textbook, as mentioned earlier, teachers should use this opportunity to explore within the classroom and use materials that they wouldn't otherwise use. So student engagement was successfully supported by pedagogical ideas such as effective questioning and group inquiry to emerge student knowledge. Overall, in order to understand the science of light and shadows, it was important that both myself as the teacher and students within the learning process recognised and understood that it was the body of knowledge accumulated at the start of the lesson from the concepts, theories and discussion which taught the generated understanding and questioning throughout the investigation.